Welcome back. In our first conversation, we kind of kicked things off with your vision for software-defined manufacturing, where Agentic AI acts as the brain and central nervous system, I think is the analogy we used. In our second episode, we got more into the muscles, if you like, of the operation, where we talked about the rise of physical and embodied AI in robotics in particular. And what we really want to do in this third part of our ongoing discussion, because I'm sure we're going to talk quite frequently as things evolve, because they're evolving really fast at the moment. But in this third episode in our series of conversations, we're going to try and connect those first two. And today the theme is really on what I'm calling physical intelligence, but really it'll kind of bring us about how you connect that, the brain and the physical. So the core of that, I think the brain requires some evolution in thinking of the digital twin, right? And I think that's really where our conversation is going to go today. So let's unpack how AWS, in partnership with your industry ecosystem and industry leaders, is kind of building the digital twin not as a static model, all right, as we maybe have traditionally thought about it, partly because of its roots in things like CAD and PLM, but as a live learning environment that serves as the foundation for the next wave of industrial autonomy, or the software-defined manufacturing that we kind of kicked off the series with. So over to you. You know, the term digital twin is everywhere.
Yes.
All right. But I need your definition or how AWS thinks about it.
Yeah, sure. And first of all, thank you for having me back. So AWS, because the term digital twin, you speak to 10 people, you get probably 10 different answers of what a digital twin is. We've actually done our own kind of definition of a digital twin, and we look at a digital twin at four levels. So level one is very much kind of that descriptive digital twin. It's probably what most people that are not within the industry think of a digital twin as. It is either, it's a CAD model, it's a PID diagram, it may be, a scan of a factory, what done by one of our partners like Matterport to kind of create that visualization. So that's level one. Then we say we've got level two, which is very much the informative part. So this is where we're starting to actually provide data information on top of that description, either using IoT sensors, or it could be, information from a, asset application like OSI Pi, or it could be MRO data that's kind of populating what that digital twin is. And then we get to kind of level three. And this is very much where the digital twin becomes what I believe is a real value of a digital twin. Because once you have that, let's call it a object, a factory, a machine, a device, you've built that digital twin, and you can then actually then start doing what we call predictive. So now you know what it is, so you defined its parameters, you've got information that allows you to then be able to then actually start getting value from that digital twin by predicting its behavior based on particular, criteria. And then kind of the final one is the level four. This is what we call kind of the living digital twin. So this is where these models are constantly being updated and take into account the behaviors of the physical system that it's actually operating in. And this is very much where you're talking about, physical intelligence, physical AI. This level four is where we see kind of the two kind of what is the same, is kind of coming together. So, you talk about, autonomous humanoid or a closed loop control system on, a factory floor. This is really kind of that level four digital twin. But as you see, as I went through kind of the description of that, there's multiple different components that are needed to actually make up that digital twin. And, from an AWS perspective, we see ourselves really as kind of that infrastructure backbone that enables manufacturers or our partners to be able to build those capabilities, on top of AWS, from kind of that descriptive, informative level. We've got, AWS IoT Sitewise, we've got, AWS IoT, Twin Maker. As you start to get up to that predictive level, this is very much where our, machine learning kind of capabilities come in with like Amazon SageMaker. And then when you then start getting into that living part and obviously having to build, the generative AI kind of foundational models that support a living digital twin, you've got AWS Batch, and our fleet of GPU, elastic GPU enabled kind of instances to be able to train those models in that instance or those cases. So,
yeah, in our last conversation, you mentioned the importance of partners like NVIDIA and kind of, you can't mention GPU without me thinking about NVIDIA. So, maybe let's dive into that a little bit. How does high fidelity physics-based simulation within a digital twin, what I'd call a simulation first approach, at some point, I guess we might end up talking about physics-informed neural networks and how those are evolving as well, but that's a future conversation, I think. But how does this change the game for developing and deploying the physical AI systems that we've been talking about?
Yeah. So I mean, we probably could spend a whole, hour podcast talking about kind of, NVIDIA. But, within their kind of their capabilities, obviously, at the low level, I should say low level, but kind of at the compute level, obviously you've got their GPU enabled chips. Jetson is a great example of the chipset that runs the computer at the edge where those models can be actually deployed in the cases of the factory floor environment. Before that model can actually get deployed, obviously it needs to be built and trained. So if I use robotics as an example, obviously you need to build that descriptive model of what you want to of that robot. And this is very much where we see kind of like the Isaac Lab portfolio of services kind of come in. Then obviously you need the ability to create synthetic data to be able to train the model based on all the different kind of scenarios that needs to come. And again, that's part of the that Isaac portfolio. And then obviously once you've built, trained, and kind of validated it, you then need to be able to deploy that down into its physical, location where that actual model is going to be run, on the robot or, on the factory floor and so forth. I probably oversimplified that kind of that model part, but, there's, when you talk about, I use embodied AI, for example, within kind of a robot or, a humanoid, there's probably multiple models are actually running there, so you've probably got a robotics foundation model that's interacting with a large language model that's probably actually running a VSM, a vision language model, and so forth. So there's a lot of kind of complexity and integration that needs to happen, and that's where we see kind of like from an AWS perspective where we really kind of add the value of being able to provide that kind of compute storage platform to be able to get to the point of being able to deploy those models down onto the factory floor. So.
Yeah, and a lot of our earlier conversations have kind of inspired me to start defining kind of a couple of areas. One is physical intelligence and the wide range of robot form factors, because obviously everyone seems to be obsessed with humanoid robots right now. I looked at the IFR taxonomy, and it's very traditional, a robot arm and gantry arms and all those kind of, and they define still a very important set of robotics, but it wasn't really catering for things like humanoid robotics or quadrupedal robots, and I don't think it include drones. But so we did a bit of work to kind of try and look at the broad field of robotics, or as it applies in the industrial sector, and kind of came up with a taxonomy. But as we did that, of course, we had to start talking about all the software components that are required both on the edge and to train and develop the brain, if you like. And so you'll see a lot more from ARC on kind of physical intelligence, and industry models themselves are interesting because I think if you look back at the definition of foundation models, we now all associate it with Gen AI, but that wasn't the original intent. There's a lot more industry models that we should be talking about, including kind of physics-informed neural networks and other types. So I'll be doing some further exploration of, what should we be thinking about in terms of the value of industry models. And that leads me on to asking you really about folks like Siemens, right, who are quite vocal about what they're trying to do with an industrial foundation model. Because a digital twin is, multiple aspects, right? It's only as good as its data. It needs a complete digital thread, right? So, from the design through its operation, its maintenance, etc., right? And so PLM systems are definitely part of the equation, right? And so how did your partnership, we talked a lot about NVIDIA. We can't talk in this space without mentioning them in some shape or form, but talk a bit about your partnership with Siemens and how critical they are to fueling the future of the digital twin.
Yes, I mean, there's multiple aspects where kind of coming, as we said right at the beginning, kind of digital twins mean many different things to many different people. But I think the reason why that's the case is because there's multiple use cases around digital twins, and I'll give a couple of examples, with what we're doing with Siemens. I think, even on the shop floor, when you're building a robot cell, you need to be able to, simulate, the robot before you actually start writing the code. That's very much where I see kind of, our partnership with Siemens and kind of Technomatics very much kind of, coming into play. As part of any kind of product development or kind of, factory building, there's still going to be a need for some physics-based simulation. So, obviously Siemens is, big in kind of the solvers of physics-based kind of, applications. So, and then finally, when we start talking about the, industrial metaverse, the work that, Siemens, NVIDIA and AWS have done, we've been able to, build that kind of digital twin capability within actually kind of Teamcenter is, key. So it's really kind of, we see them and our partnership with Siemens, across the board. And I should, I don't want to skirt over the fact that, if we go back to, right at the kind of the base level, a digital twin is only really a digital twin if it's got information, and in the manufacturing context, a lot of that sensor information comes from the PLCs, the shop floor. Siemens factory automation is kind of, significant, in this space. So either like running the machines from the PLC perspective, or actually then making the data available, through their industrial edge, portfolio. So
right, I certainly wasn't inferring that Siemens is the only player in that game, but I think they're obviously one of those that really has a very strong PLM portfolio, and with the acquisition of Altair, it's kind of obvious that they are a major player. And of course, they've had a long-standing relationship with NVIDIA, just like yourselves. But thanks for that reminder. There's a whole ecosystem that are going to be contributing data to that digital twin, and everyone from, the Avivas of the world to Rockwell Automation, who I know you're also working with. You're working with most of the industrial automation companies, right?
Yeah. And I was just going to say that I just want to call out a point is I think just due to the complexity of that ecosystem out there. Plus, let's acknowledge that, most factories are not brand new greenfield, they are brownfield, and they're going to have a very, disparate, technology landscape of, things from like 15, 20 years to stuff that's probably, brand new. System integrator partners, or what we call OTSIs, are going to be really kind of key into helping manufacturers build these digital twins or these physics AI systems, or physical AI systems, I should say, and actually truly get value out of, their software defined kind of manufacturing strategy.
Yeah, it's always about the ecosystem. When we talk about the industrial sector, the players evolve, the technologies involve, but to your point, it's a pretty complex ecosystem, and most of what's out there is almost by definition brownfield and heterogeneous environments, right? I wish we could all just rip and replace or build a new factory. Well, maybe I don't wish that, but
yeah.
But anyway, you also mentioned, and I know we didn't talk about this ahead of time, but you mentioned industrial metaverse, and Siemens and NVIDIA are probably the most vocal. They're the ones that seem to be still talking about the industrial metaverse. I think the hype to some extent has died down from a year or two ago. I think the pragmatic application of AI and its benefits have kind of overtaken that vision, which I still think is a compelling vision. It's kind of on the back burner a little bit, but I can't help feeling a lot of what we're talking about now are actually components of that industrial metaverse vision that we're building, but no one wants to, or not very many want to call it the industrial metaverse right now.
Yeah, I think we're all saying if it's software-defined manufacturing or industrial metaverse, we're all focusing on the same goal and outcome for manufacturing, which is the realization of Industry 4.0 is really around, how do you make the people that are actually building the products or manufacturing the products, how do you provide technology to them to make life safer, easier, and more productive around that? And, software is really a real key enabler for that. But at least for us, we see AI, and I'm using AI as a very generic term, going from like machine learning to generative AI and agents, is really kind of the catalyst of what's actually going to deliver that in realization for manufacturers. So,
okay, well, maybe let's kind of bring it together with our previous conversations. We have the agentic AI brain that we talked about in episode 1. We have the kind of physical AI muscles we talked about in episode 2. So how does this live, data-rich digital twin that we've been discussing now today act? And I'll bring it back to kind of the idea of world models that are kind of emerging, right? Obviously, somebody we've talked about already is very vocal about one of those world models. Actually, two of the vendors we've talked about, right, are both talking about different kinds of world model. One very much focused on the engineering or design to manufacturing. Another one more on the, just almost the general physical world, right? In the case of NVIDIA. How does those world models really help us close the loop, allowing the agents that everyone's excited about, test scenarios, learn, and then they've now got the physical systems to go and execute, right? But there is that learning and adapting to these real worlds that needs to happen, I think, for all of this to scale safely and pragmatically. So thoughts there on physical systems with true intelligence and the role of kind of world models in helping us close that loop and bring that to fruition?
Yeah, I think this is a very evolving space, as of today. And if we think of true kind of autonomy, those world models are going to be critical for the product, the device, the robot, whatever it may be, to be able to, to interact and work within the environment that is in, type thing. And I think there's association, at least in my thought, that world models are probably more kind of aligned to humanoids type thing. But like if you even go, probably more what we're seeing manufacturers do today is, look at kind of cobots, for example, and then how can, cobots, evolve to be more aware of their surroundings so that they're not just following a standard cycle. They actually have a dynamic policy that's adjusted based on the environment around it and what it's actually sensing, or it can view using kind of computer vision and so forth. For us, we see that kind of like AI and robotics is probably going to be, say, combination of machine vision, SLAM, reinforcement learning, dynamic policies, LLMs, and then kind of world models as well type stuff. It's a very kind of interesting and an evolving space, and to see the ecosystem very much kind of grow around this. Obviously the OEMs themselves obviously going to be investing heavily in building capability within kind of their products that are going to be used on the shop floor. We're seeing a lot of startups come in this space. Liquid AI is one example. Yeah, and then obviously we're going to have the traditional providers who obviously want to build capability here as well.
Yeah, and I would probably add, because I take your point, world models, ultimately they're trying to translate Gen AI scale kind of to the physical world in some ways, right? But there's a lot to be gained by being able to define just a workspace, and so you don't have to define the whole world. You can kind of get a lot more granular when we're talking about robots and people, right? Interacting. So your point about the cobots in a well understood and defined space is somewhat more practical, and we can get there, I think, a lot quicker. And your point on humanoid robots to some extent, because they are conceived to be these general purpose and more likely to be interacting in the home or looking after elderly people, so not just in industrial scenarios. So it's an important distinction. In industrial applications, we tend to have a little bit more control over the environment.
Yeah.
But it's still incredibly dynamic, right? And so we have to still have that ability to adapt and react and learn and evolve. But looking ahead a little bit, I think we are already looking ahead quite a bit, right? But what is the next evolutionary step? Could we see not just Gen AI, but Gen AI as part of industrial AI toolset moving or taking us beyond planning tasks to actually designing and optimizing new factory layouts or robotic work cells, kind of changing or adapting the digital twin?
Yeah, I mean, I think it's could be a lot of uh, micro increments across the whole landscape is what we're going to see kind of in the near future. I don't want to discard the fact that I think machine learning for applications like predictive maintenance are still the 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 AI tool to be used. And I think that's going to evolve very quickly with agents. And actually, you're not just, I think we spoke about this in the first episode, you're not just predicting the machine is going to fail or an asset's going to have a failure, but you want to kind of automate that process so that the service engineer gets notified that they actually need to perform a task rather than the ML model just outputting, the fact that it's detected a defect or anomaly and it's going to be a failure. I think when it comes to digital twins use in production planning, I think that's going to be, really kind of key into one, as manufacturers, are building new factories, they want to be able to do as much planning, simulation upfront as actually possible. And that's just not just kind of the layout of that actual factory, but how do they simulate running the actual product through the factory, and down to kind of the robot cells which we're talking about earlier on with like technomatics as an application, programming that. But I also see kind of like that generative AI is really going to play a key part in kind of the whole software defined and writing the software for the applications of the industrial machines, robots, and so forth. We've just recently completed a POC where we actually used Amazon Nova to actually write the robotic program based on a couple of inputs. I need a robot to do X, Y, and Z, and obviously it's got access to the manuals and of that actual robot and the kind of programming language, and it actually outputted that program that's actually going to be loading onto the robot type thing. So there's a huge amount of efficiencies that we'll see kind of, I think, coming in the next near future. I don't want to put a timeline on it, but yes.
Yeah, and I guess that's where my question was a little bit convoluted, but that you've kind of brought us back around. That's really where I wanted to bring us back to. At the back of my mind, it's if I have to be critical of where we are after the last few decades of kind of monolithic stacks of layered technologies, I think one of our biggest barriers often is the complexity in reconfiguring a PLC, or let alone a robot, right?
Yeah.
Where programming a robot to do something safely is not trivial, and very often that's what constrains making changes on the factory floor. So the vision of software-defined manufacturing, where I can take a lot of that complexity away and blur all of those layers of software and have agents probably sensing the environment and updating whatever the orchestrator is. And that's a whole different theme we should probably get into at some point. Is we've got lots of different software evolving now, and as I look at the evolution of kind of agents and more flexible robots and automation systems that can be driven by software, how do we orchestrate all of this? What's the new orchestration layer that's going to let us manage this? So, we used to talk about business process management at kind of at the enterprise level, and then we used to, at least I used to, talk about operations process management because it was a lot more granular and had to deal with a lot of the time sensitive issues. So you couldn't necessarily apply business process management tools in a factory, partly because you had a lot of unknown context and it wasn't all transactional, right? So I feel like we're in for a fresh wave of an evolution of almost every piece of software that we've got used to in the old ISO layered models. And maybe that's a whole separate conversation, Steve, but I just couldn't resist as we were talking through that. It was like, okay, we've talked about agents, we've talked about robots, we've talked about how they're going to look. But at some point, we're orchestrating agents, people, and robots, or let's just make that a bit more generic. Let's just say physical systems, right? And it feels like we need a whole new paradigm to do that, because it's going to be a very different mix of people, agents, and physical intelligence.
Yeah, I agree. I mean, I think, I don't believe we're ever going to, well, maybe I'm wrong. I was going to say, I don't believe we're ever going to get rid of the system of record. I think those systems of record, be it like the ERP and SAP, or it be like MES with kind of like Siemens Ops Center, or, Rockwell Factory Talk, are still going to be there. I think they're going to evolve with those ISV partners bringing agents into the applications so they can actually, automate and orchestrate processes. Really, where I see it's going to come down to those applications with that capability, plus agents and, wrapping around that to really make it, those transactions and events be as most efficient and as productive as possible type stuff. So, going back to, the ISO 95 model, generally when I'm presenting at conferences to customers, I talk about kind of the evolution of manufacturing, with like starting off with like the ISO 95 Purdue model. And then like most people, there's kind of this hybrid stage where they've still got those systems of record, but they're really kind of building an industrial data lake, and they started to put, ML and Gen AI and agents on top of it. But, what we're talking about, here is that right hand slide where systems, I use the word systems, can actually interact and talk to each other. So, for example, we'll take, one machine that's actually feeding, a robotic cell. Let's say there is a stoppage in that robotic cell. Is there a world in the very near future where a human doesn't have to come in and get involved in actually, stopping or slowing down the machine that's feeding that robotic cell? That robotic cell can send, an event to that machine. That machine has actually got the intelligence in it and the software in it to be able to understand that situation and like slow down production or potentially stop production so that you don't actually get this bottleneck and feed. I mean, this is truly, bring it back to the thing. This is really where we see, digital twins come in, because really what it is, you're going to have a digital twin of each of those machines, robotic cells, but then you're going to have digital twins of digital twins that allow you to be able to create this true orchestration, of a factory.
Yeah, it feels like we have a few more conversations as this continues to evolve, Steve. Before I kind of maybe wrap this one up, any closing thoughts? I mean, we've had a great conversation as always, but did I forget to ask you something that you really thought should be part of this conversation?
No, I think we've actually covered quite a lot in today's. No, no, I mean, I think one thing I want to reiterate is that I know we've been, talking about a lot of stuff that's kind of potentially could be futuristic, and I really want to, bring it back to, I don't believe this is going to be a big bang approach. It's not like going to be like tomorrow or Monday morning we're going to be there. It's going to be very much a evolution of small incremental changes for manufacturing, and it's going to be very much driven by use cases, that have, you know, ROI to, you know, that the manufacturer. You know, how can they actually, you know, produce products, you know, as efficiently as possible and ensuring that their people working in the factories are safe and they're making their jobs as easy as possible. So, you know, it's ranging from, you know, using machine learning and computer vision to identify, you know, defects in the manufacturing process, to building kind of knowledge-based systems for either being able to capture tribal knowledge or give information to the people working on the factory floor or running, you know, the factories to be able to make informed decisions, either by building applications or embedding those applications, those knowledge systems within, you know, their systems of record, their MES, for example, through to starting to look at, you know, embodied AI and how robotics can really kind of help drive more efficiency and so forth.
Yeah, and I think that's a great way to bring us back. As you know, when I kind of started at ARC, my first report was on the industrial AI revolution, but I put the R in brackets because I thought it was going to be, you know, we have safety, we have mission critical factories to run and operate, and those don't change overnight. So your points are very well taken. Having said which, I'm seeing things moving a heck of a lot faster than I thought I would. And so I'm excited about the future of manufacturing. I'm hoping that all these technology evolutions are also going to bring people into manufacturing, because that's obviously one of the constraints that we've been dealing with a long time. And that's really where I think the role and value of AI in simplifying or making very complex processes more accessible has a much bigger impact than we really think. Just making it easier to get at data and train people on the fly is incredibly valuable. And yes, we're talking about futuristic topics. You know, humanoid robots and other types of robots may take some time to really get deployed at scale, but they're happening already. I think we can all point to use cases where it is already happening.
Yeah.
Maybe not at the scale that we can say it's yet a revolution, right?
Yeah. I mean, to that point, I mean, I'll use Amazon, you know, as a example of that. You know, we started our robotics journey in like 2012, you know, when we acquired, you know, Kiva. And, you know, we've been, you know, investing in robotics, you know, across our fulfillment centers, to really kind of, you know, do as we, you know, as any manufacturer is doing, you know, how do we be more productive? How do we make people in the fulfillment centers make their lives more easier, kind of safer? And then we've just hit, you know, a key milestone, you know, this year where we've deployed over 1 million robots, you know, across our fulfillment centers. You know, and that's, again, you know, there's multiple different applications. You know, we just recently kind of announced kind of, you know, Blue Jay, and then obviously we had Sparrow. And obviously, you know, earlier in the year, I think we spoke about the second one is, you know, we've got Amazon Deep Fleet, you know, which is our own foundation model for managing the you know, the robots out there and making them more kind of continually optimizing that fleet performance. So yeah, it wasn't overnight for us.
Yeah. I mean, Steve, this has been another fantastic conversation in our ongoing dialogue. We started with software-defined vision of agentic AI because agentic AI was hot, and that seemed like a great kickoff point. But I think we've moved to the factory floor, which obviously for ARC's audience is what it ultimately translates into, with conversations on physical and embodied AI. And today we've hopefully tied it together somewhat with, you know, digital twins are definitely not dead. No. Digital twins are going to continue to evolve, and they are the intelligent engine that's going to enable true autonomy. As far as that autonomy is going to apply, it's always a balance of people processes and technology, but certainly everything is pointing to more intelligent autonomous systems being a bigger player in that mix. It's clear we're in the early stages of a profound transformation in manufacturing. We can debate whether we call it a revolution or an evolution. What we can say is it's getting more intelligent, adaptive, and autonomous every day, as you just highlighted with Amazon internally. Maybe more on the warehouse and supply chain execution side, but nevertheless, I view supply chain as part of manufacturing, right? We all have to deal with supply chain issues. So thanks very much for sharing your insights in the AWS vision, and that continues to evolve and shape the market. So I'm already looking forward to our next conversation. I think we teed up a couple of topics for the future, but thanks very much for episode number 3 is in the can, I think.
Yeah. Thank you, Colin. It's good to be here.